Here's number 5. We have this picture that shows there are two rods of mass m and height L, and in between them, there's one rod with a mass of 3m and a length of L. And we need to find the location of the center of mass of the assembly. To start, I'm going to say where my origin is. My origin is going to be the bottom left of this first vertical rod. So I'm going to draw my coordinates coming off of this. That will be my x, and this will be my y. And I'm going to also say where the center of mass of each component is. The center of mass of this vertical rod is going to be in the middle of it. And the same thing for this rod over here. And the center of mass for this rod up here is also going to be in the middle. If you imagine this is a roller stick and you put your finger right in the middle, it'll balance. So your finger is going to be on the center of mass. I'm also going to say what's positive and what's negative. I'm going to say that up is positive and right is positive. And the advantage of setting my origin to be at the bottom left of the whole picture is that any point I'm plugging in here is automatically going to be positive. Now to find the center of mass of the assembly, I will first find the center of mass of the x, and then I'll find the center of mass of the y, and then use those to find the center of mass of the whole assembly. So the center of mass of the x is equal to the mass of this first rod times the x position of the center of mass of the first rod plus the mass of this second horizontal rod times its horizontal position, which will be, I'll just call x2, and then I'll add that to the third rod, which will be m x3. This is all going to be over the total mass, which will be m plus 3m plus m. So x cm is equal to, and it'll be mass times the x position of the center of mass of this first rod here. Well, the center of mass of this first rod here is right here. And this doesn't have any x component. It only has a y component. So for this, its x position is going to be 0, and it'll cross out. So for the next rod, it'll be 3m times this x position will be L over 2 away from this x origin. So I'll write L over 2, because it's only half the length of this rod. And so the next one is going to be m times L, because it's located one length away from the x origin. This will all be over the total mass, which is 5m. And so when you simplify that, you'll get x center mass of L over 2. And doing the same thing for the y, we'll do y center mass is equal to my1 plus m, this will be 3m, y2 plus m, y3. And this will all be over the total mass of 5m. So the y center mass will be equal to the y position of this first rod is L over 2, because it's half a rod's length away from the y origin. So it'll be m times L over 2 plus the position of this rod here is going to be 1L, this height here, away from the y origin. So it'll be 3m times L plus this rod over here is going to be an L over 2 distance from the origin. So it'll be m times L over 2, and then it'll all be over 5m. So the y center mass, when this is simplified, will be equal to 0.8 m. Now that we've found both the x center mass and the y center mass, I'm going to draw my coordinate system and find the total center mass of this assembly. So I'll draw my x and y axes. That'll be my x, that'll be my y, and I'll just draw the diagram here. There's one rod that goes vertical there, one rod that's horizontal, and another that's vertical. And this here will have a length of L, and the base here will also have a length of L. And our x center mass is L over 2, so that'll be in between here. That'll be L over 2. Our y center mass is 0.8 L, which will be just beneath this point here. So that'll be 0.8 L. And these meet somewhere around here. So it'll meet 0.2 meters below the top rod center of mass. So the center of mass of the assembly is going to be 0.2 meters, because it tells us that the length is 1 meter. So this will be 0.2 meters below the center of mass of this top rod. And that is your final answer. Thank you for watching.